Hello, everyone, and thank you for joining today's session. My name is Irina, and I'm the event planner for the Redmond Reactor Space. Before we get started, I have a few things to go over. Please take a moment to read our code of conduct. We seek to provide a respectful environment for both our audience as well as our presenter. We do encourage engagement in the chat, but please be mindful of your commentary, remain professional and on topic. Useful links will also be shared in the chat. This session is recorded and will be available on demand in 24 to 48 hours on the Microsoft Reactor YouTube channel. Which brings us to today's session. The session will run approximately 1 hour with questions throughout, and our speaker today is Sam Wronski, who is a regional cloud advocate. I will now turn it over to Sam.
Great. Hello, everybody. I am Sam Wronski. I'm a regional cloud advocate here at Microsoft. My job is to help empower all of you to build really cool things with Microsoft technology. So what we're doing today is kind of building off of what we were building last week and a couple months ago. Last week we were looking at Azure Functions and how you can use Azure Functions to build really cool serverless solutions that can run in the cloud and be scheduled without you having to worry about maintaining infrastructure and servers to actually run the code. You can just write the code and then it works, instead of you having to write and maintain that code in a way where you have to actually have some kind of server that manages it. That's sort of the idea behind serverless. So now we're going to be kind of expanding on that. We're going to be reviving our old project of Flappy Cube, which was kind of an introduction to how to build games in Unity. And we were introducing a bunch of PlayFab features. So one of the features of PlayFab is it allows you to actually add Azure Functions as a function to certain other events in the tool. And so that means that we can actually trigger our Azure Functions directly from events in our game. And so that's sort of what we're going to be looking at how to do today, is how do we create some new Azure Functions? How do we set all of that up? And then how do we do all of that? So I've already implemented everything. And then we're going to just kind of do it all again. Hopefully, because this time I know what I'm doing, it'll go quickly and fast. And so that's our plan for the next 50 minutes or so. Feel free to ask any questions. So if there's anything you would like to know, or any questions that you have for me, send them my way, and we can kind of just inject those in throughout the stream. And so yeah, let's get started. So first off, we're going to start with just our game. We're not going to cover the entire thing here, but just to kind of give a foundation of what's going on. This is Flappy Cube, which is a PlayFab-enabled Azure tool. I guess it's a game very similar to potentially some other mobile games you might have played, and it lets you do cloud things inside of it. So in this case, we have our user named Test, and so we can actually just log in here. And this is going to give us our high scores for this user. So we have a number of things with different high scores, and we can actually start playing this game and actually get a new high score. So this is the current user's high score and the current game's high score. And then we lose a few times. So this will keep recycling and resetting the scene every time we lose. But what that's doing is actually sending a bunch of functions and a bunch of events up to PlayFab. There's a whole bunch of things happening when we do that. So let me kind of take a look here. So if we jump over to our overview, this is what's actually happening here. A lot of this is empty because we're not using a number of features here, but we are using a few of them. So we have players here. So if we look at our players, we can see when people have logged in. This app was created about 3 months ago, so these users have not signed in a number of days since January. But we can take a look at this test user, which is who we just signed in recently as. And this user has a whole bunch of information assigned to them. They have things like a username, how much potential value they've spent on this game. So if you want to monetize your game or something, they have information about that. And then they have a bunch of other things that we can actually take a look at. So there's a few things that we kind of care more about. And so we're going to take a little bit more look at those. So there's statistics here, which tracks different statistics about the player throughout the game. We manage this game's played automatically. So the player doesn't have the ability to actually go in and edit the number of games they've played. Instead, that's tracked every time you lose a game, every time you get a game over. This increments by 1. So that's a custom script that we have. That's sort of, if you don't want to completely go into coding your own behaviors, there are certain basic behaviors that you can actually attach to these things. So that's how a number of these things are getting set. There's also segments. So we can see which segments of our user base this user is a part of. This is intended as a way to identify users who are doing specific things. So specific behavior patterns or whatever users are doing, you can use that to detect things. So in this case, we have this person is a member of all players and players who've played a bit, which was a custom segment that we created. I think that means they've played more than like 5 minutes or something, or like 50 games. And so this user has 200. So that's why they ended up here. But you can use these as a way to target specific features for specific users that are maybe users who played in the first year, or users who have achieved a certain status in the game, or whatever you're trying to do. You can use that as a way to do that. And we can actually tie functions and behavior to when these segments change. So if a user gets added into a segment, we can send out a congratulations push message to their phone or something, or do other fun things. And so that's that. And then the final thing I think we want to take a quick look at is PlayStream. So the PlayStream is empty right now. But what this shows is a real-time series of events for this user. There's 2 ways to view this if you're getting started with PlayFab. If you are getting started with PlayFab, there's a link in the chat there for writing the PlayFab cloud script, which is what we're going to be getting to. And you can also go to playfab.com to create an account and get started and set all of this stuff up. Everything that I'm showing here, I've built on just a personal free version of PlayFab. So there's no cost associated with what I'm showing here. So there we go. And then let's jump over to some of the more fun stuff. So we want to take a look at the segments here, just because we'll be coming back to this. We have a list of all of our players. So a player who's played a bit, if they have a games played greater than 3. So this player has played, our test player has played more than 3 games. They've played about 200. So they end up in this segment. So this is how you define them. You just give it some sort of boundary to define who ends up in which segments. In this case, we have a statistic for the games played. And we're saying if that's greater than 3, then add them to this segment. And that just lets us kind of identify that. So the next thing we're going to do is kind of jump into our automation bit, which is actually sort of the goal here. We're trying to add stuff here. So previously, when we were walking through and creating this game, we skipped over this page because we just focused on setting up rules to kind of manually do some of this stuff. In this, we're actually going to be implementing these functions. So we're going to create a function app, we're going to create a function, and we're going to make it something that we can actually invoke from this page. So what we want to do here is jump over to our rules. And this is our rule for when the player actually loses. So there is a name here, an event type. So this is the actual thing that ties the event back to this. And then there's actions that are going to be taken. So in this case, we can increment a player statistic of games played. And so every time we get this event, we just increment a statistic on that player by 1. This allows us to actually keep track of the number of games played. And the advantage of all of this is it's not happening on your client. It's not a client-side code that you're running. Instead, what you're doing is actually sending an action up and saying, this thing happened in the game, potentially with some arguments or something, react to that. And the cool thing with that is it means that players can't hijack your statistics or whatever. They can't come in and say, I've actually played 20,000 games. Or actually, I've only lost 5 games and won 6,000, or however they want to change that. Because these values are stored in the cloud and they're only able to be modified by actions rather than being explicitly invoked, it limits how players can interact with those and change them. So that's that. So I think the next thing now is to actually start implementing some of this. So let me close a bunch of this stuff because we don't need that. And let's start adding things. So this is the functions that I've already created. We're going to kind of reset and delete most of this because we don't need it. So let's go here and just create a quick resource. Let's do a resource group. So we're just gonna, that's not the right thing. Let's create a resource group. Oh, there we go. So whenever I'm kind of testing something out or trying something new, my first go-to is to create a new resource group. The advantage of doing a new resource group as opposed to like a testing resource group or something is you can clean up things really quickly. If you ever want to just reset and undo everything that you created as a result of that project, you can just delete the resource group and it will all go away with it. So that makes it clean up a little bit easier as opposed to putting everything in one resource group because they all fit there. Then you have to actually figure out what's assigned to what and how everything's related. So I just find this easier. So let's do Flappy Cube functions. I think this is new. And so we can create this. And so now that we've created this new resource group, the next thing we're going to do is actually create some functions associated with that. So let's go back here and create our new functions app. And we're going to throw that into our same Flappy Cube functions resource group, the one we just created. And this will be our Flappy Cube functions stream. And there we go. I'm going to, again, with Azure Functions, you can choose whatever stack you want to run this stuff on. So depending on the stack that you're building on, you can choose whichever one makes sense to you. For this, I'm going to choose .NET because we're kind of building a Unity app. And so by picking .NET, hopefully it means that we can kind of grab everything and use it all together. And ideally that way, everything is kind of just a .NET base instead of we have something in Java and something in C#. It just keeps everything the same. And then for region, I don't know if I switch this on the resource group, but let's set this to West US2. For regions, when you're invoking things, setting it to something in a development environment that's close to where you are is typically the best choice because there's less time for the messages to travel between those two things. And then the rest of this stuff, we're going to keep this on a consumption plan, so it's only charged when we are using it. We don't need to spin up any VMs or anything to actually host this. And then let's do this. We need a storage account. It will automatically generate one for us. Networking, I don't think we have to do anything here. And then monitoring, we'll turn on application insights, which will give us a little bit of telemetry about how this application is working. And then tagging, I don't think we need any of those. So let's go and create this new function app. And so we kind of covered this last week, but when you're creating a function app, that is not your Azure function. The function app is sort of the host and storage component, sort of the management plane, the control plane of whatever you're running. And then all of your functions will get appended to this. So in this case, we're setting up a few different things. We're actually setting up a storage account to store all of our configuration information, and we're storing the actual Azure function app. So there'll be multiple things added to the resource group we created. One of the reasons that actually using its own resource group is nice is because this is going to trigger and create more than one resource for us. So once this finishes, we should be able to actually start creating our Azure function. Previously, we did this all from the main page here. We did this all from the portal. And you can still do that. But for me, I tend to prefer my IDEs over the embedded ones. So we're actually going to switch over to Visual Studio Code and start working from there to actually start creating our function app. So let's do that. I already have created some, so we're going to actually I'm trying to think the best way to do this. Let's go and create a new directory here, and let's make that much bigger. And so we're going to make a new directory, and this is going to be our Flappy Functions. That's a cool name. So we're just going to create a directory for us to store these functions in. And then we are going to jump into here, which is, these are the previous ones. And now we have Flappy Functions, which is its own separate thing. So let's create a new project, a new Azure Function project. And that should hopefully initialize something. One issue is it might be detecting the one that I already created, which I didn't really consider. There it is. Perfect. Awesome. Haven't done multiple projects from the same root directory before. So that was why I was a little bit questioning that. But we're just going to select a few things. And let's do .NET 6. Select a template for your project's first function. And let's just use an HTTP trigger. So this is just creating our project. These are similar questions to what you'd get if you use the portal, but they're just coming through Visual Studio Code instead as a way for us to edit these. So let's do interact with PlayFab. Cool. And we'll stick this into reactor.flappycube as our namespace, and then we can assign different access rights for this. You can use whichever one you prefer. If you make this anonymous, there won't be an API key associated with this, which means that anybody is going to be able to call out to this function, even if they aren't going through PlayFab or your game. Whereas if we use a function, it can be invoked by PlayFab or anybody with that API key, but not by anybody else. So typically, you're probably going to want to use a function for this. Typically, you do not want people to just start invoking functions randomly. And there are still ways through PlayFab to actually invoke functions directly. So we're going to just choose a function auth. And I already have tasks because this should be fine. We can overwrite those. The tasks there are set up to actually like automatically build and deploy things and run certain functions thing. I already have one set up for this root directory. So it's just asking to overwrite those. So that's totally fine. And then we get this. So this is our Azure function. It does a few things. It's called interact with PlayFab. That's the name of the class too. And then what it's going to do is very similar to what we already have done with the JavaScript version. It's going to ask us for a name and print that back. If we provide one, otherwise it's not going to do much. It's just going to print back. I believe this was triggered successfully. And so with this is enough for us to actually deploy this out to our Azure function and get started. So let's do that. So what we're going to do is deploy to our, what do we call this? FlappyCube function stream. And so we can select the name or the project that we wanted to deploy to. It's going to ask us if we want to override. The way this works is it's going to build your project and then ship that binary up, which means you're no longer going to have access to be able to live edit the code. Instead, you're shipping up a full binary with all of your functions packaged together. And so that's why it's asking if we want to override. If you try to just deploy like one function and you have a project with potentially 10 or 100 functions in it, all those other functions would go away if you just deployed a binary with that one function in it. So that's what this is asking about. And so if we click deploy, that should be good. And it should start packaging all this stuff up and send it out to Azure for us. Now, there's a few other ways to kind of interact with this. And so if you have the Azure Function app or Azure Function extension installed inside of Visual Studio Code, you can actually go into here and start browsing a bunch of different things. Some of these things we don't really care about. There's API management and app services. We can close those, but the thing that is kind of cool for what we're doing is this functions stuff. So we actually have a list of all the functions here, and we can actually browse and explore these. So once this deployment finishes, we should be able to actually see that out here. inside of Visual Studio Code without having to go back to the portal and switch back and forth. This also gives you nice ways to interact with it and view logging, for example. So if we want to see invocations of this function, or just what does the current log stream look like for this function or this set of functions, this gives you a way to do that. So it can be a nice way to kind of integrate that directly with your development environment and make sure that you're actually executing things. So there it is. Deployment completed. Cool. It's behaving slightly differently than the one that I built. So we'll see what happens. But I'm going to refresh this quickly just to make sure everything's up to date. And then I should have named this differently, but we have a floppy cube function stream, which is where we deployed that. And so we have a series of functions. And then here's the one that we just deployed. So we have interact with PlayFab, which matches the function name that we deployed. And so we should be able to grab that here. And I don't, we can. We can just copy the URL and invoke that. Let's go and see what happens. This is going to give us our API key, looks like, as well as our invocation. This is Nightingale. If you're unfamiliar, it is a REST app for interacting with things, very similar to something like Postman or other options, if that's something you want, or a curl if you prefer a command line. It does the same stuff. This is just the one that I use. And so we run this and we get our response back. So now what we've done is pretty much without leaving Visual Studio Code after creating the Functions app, we've created a new function, we've deployed it, and now we can actually interact with it. So what I'm going to do now is grab that same function, and we're going to integrate this directly with PlayFab. So what we really want is we want PlayFab to be able to call this function for us. We don't want to be calling out to our game with this API key, because if you put your API key into your game binary, somebody's going to grab that and they're going to use it to do all sorts of things. So typically we don't want that. What we want is some way to directly invoke this. Or to indirectly invoke this. So say this event happened, or this backend thing happened, or this timer elapsed. Now let's run this thing. And then from here, we can actually integrate pretty much with the rest of Azure, because we now have an Azure function that can go out and ping other services or do any custom code we want. It's run entirely in the cloud, off of any client machines, which means you don't need to push out new binaries if you need to update this function, for example. So we're going to grab that same URL and jump back over here to PlayFab just to show everything's still here. Here is our interact with PlayFab. It's the same thing. And you can also see this one's marked as read-only mode. That's because we deployed a binary with all of our compiled functions. It's not the editable code like we had previously. And so with this, we have all of our normal stuff. We go into code and test. It's less helpful because again, it's read-only. So you're just going to see this. You're just going to see the function configuration. You're not going to see the actual code for this function. That should be in your repo or something like that. And so that's all of that. But if we go into PlayFab, we can start doing fun things. So let's go into Cloud Script and register a new function. And so what we can do with this API or with this screen is set up a function to call. So we can just paste that function URL, including the code. This includes the authentication code. If your auth code ever leaks, you can come back and update this function URL without regenerating your functions, so you won't break anything. And then we can choose our function name. There's two types of triggers. I've mostly focused on learning HTTP stuff, but you can also integrate directly with queue-based triggers if that's what you're building with. So those are the two options. And let's say interact with, or let's call this Hello Azure Functions. And so this will be our function name. We can register this. Spaces are fine. It's just a helpful name for you. And then we get this. With those names, just make sure it's something that's actually memorable and something you can repeat. Having different naming syntax gets a little bit weird. But that's it. That's the function registered. And now this is something that PlayFab knows about. It's something that it can go out and run. So without editing our game at all, we're going to integrate with this function. So we don't need to go into our game and say, oh, also you need to call this function and run this, because that needs to happen too. Instead, we can say, whenever the player loses, let's add some extra actions here. So previously we were incrementing a specific statistic. Let's also go and execute an Azure function. So here we can see it already detected from our list. Cloud script Azure function, hello Azure Functions, that's already there. And we're going to also publish the results as a PlayStream event. What that means is that the result from this function is going to be published into that PlayStream list of events. So that's what you can use to see like player actions in your game and things like that. And we can just save this. And so if I go back into play in our game, we will see a few different things. I'm going to slightly change this. So we're going to actually open up this PlayStream monitor and then scroll down here. And then I'm going to actually take this off screen quick and just run the game. And you should see a whole bunch of events start popping up as we actually start interacting with this. And so we'll see what happens. And you can actually tell what's going on in the game just from these events. So that was the login. You can see we have a player logged in. You can see who logged in and the device info. This is all stuff that we built previously. But then if we actually go into playing and play maybe a little bit enough to get a score of more than 1 and then lose, we'll start getting a bunch more events. So I lost 3 times there. So if we jump down, we can see player lost. That's our event. That's what was previously happening. Let's just throw that over there for now. The player lost event is what triggers all of this stuff to happen. When we get a player lost event, we trigger all these actions, which is causing our statistic to be incremented and for action to be run. So you can see here, we triggered our Hello Azure Functions event just from this event. And so we can actually take a look at what came back here. There we go. Whole bunch of fun stuff. Here's the execution result. So we can actually see for this event how long it took to execute this function, 270 milliseconds, about a quarter of a second. And we can see the result. So this HTTP triggered function executed successfully. So you can see the name, the function result, and so on. You can also see any errors that might have occurred if there was a issue or your server returned something that wasn't a 200 success. You'll get that information back here too. So there's a way to look through all of this information. You can also see what the event was triggered with. So you can see what was causing the event to be triggered, and you can see who triggered it. So in this case, we have our triggering player information, which includes all the statistics and information about that player. So you can actually see what's going on here and what's causing all of this to happen. But that's that data. And then we just keep having more of these events because I lost 3 times. So we actually, again, invoke this other function and get a response. So that's how all of this integration starts working, is you can actually just start triggering these directly from events. And again, we didn't change any of our game code. Nothing changed. This was all done just by modifying the upstream stuff, all the stuff in PlayFab and adding on Azure Functions. So now we can actually push updates to this function. We can do all sorts of stuff, and all of this will continue to work. So again, we don't need to change our game to change behaviors or integrate further with other parts of our infrastructure. So I think that's really cool. This is one of the things that I think I was really excited about. So that's that, but there's more we can do. There's other ways we can actually start integrating these events. So there we go. Let's jump into this. I'm forgetting where I wanted to go. Nope. Let's go into players and jump into our segments. So like I said, you can actually trigger events based off of players changing segments. So in this case, for example, we have lapsed players. So maybe there's a list of top active players or something. And so if there is a function, that you have where you're maintaining a scoreboard of active players. Maybe a scoreboard isn't the best thing because there's actually a leaderboards functionality here. But if you're doing that and you want some way to actually trigger based off of segments being entered or left, there is another actions thing here. And just like other things in PlayFab, when you want to trigger an action, that can include these Azure functions, which means you can start invoking all sorts of other fun stuff. So we can just add an action here to invoke our Azure function like that. And the integration is the exact same, regardless of how you're trying to work with this. And again, no game changes need to happen to make this work. So it just happens. And then left segment. So if you ever leave this segment, for example, you come back to the game and start playing again, we can also fire this action. You might want more than one for this. You might want something that's doing something a little bit more than just firing the same action over and over and over again. But this gives you a way to kind of inject that kind of behavior. So I'm going to remove these because I don't really need any of this behavior for segments stuff. But the other fun thing is we can trigger this off of leaderboards. So when a leaderboard resets, or there's something to cause your events to restart or reset, you can trigger off of that as well. So we have a series of high scores, for example, or a scoreboard for our games played. We can actually jump into this and update the prize tables that are determining this and have certain functions get run for each user that is in, say, this is the top 10 tournament winning players. So this triggers, I believe, at the end of a quarter, but this will be the top 10 tournament winning players. So if we have a series of tournaments, this will select the top 10 from all active players and run the following events. So in this case, we can send them a push notification and increment the number of tournament wins they might have had. Or again, we can execute an Azure function. So for example, if you want to congratulate your player of the month or something on Twitter, or do some other integrations with a broader code system and inject custom behavior based off of some of these different events, this gives you a way to do that. This lets you actually start adding this behavior. So that's what's going on here. Yeah. So I think that's mostly it. So now I think we should jump back and actually take a quick, deeper look into what's actually happening here, because we didn't really look that deep into what's actually happening, because we're not just getting a function invocation. PlayFab is actually sending us a whole bunch of extra information that we can actually use when we're working with these functions to do cool things. We don't just have to guess who the player is that the function is being invoked for. We're getting that information. We're just not using it yet. So let's take a look at what that is. And here's how I guess find that information and learn more about it. So we have our Flappy functions, interact with PlayFab. There's a bunch going on here. But the interesting bit is this RequestBody. What we're doing right now is grabbing data and then trying to extract a name, because this is just the default Azure function. This is just hello world in Azure Functions. But there's actually a lot hidden here. We're just not seeing it because we're using a dynamic object. And we're just kind of saying, if there's a name, then use the name. Otherwise, just ignore it. So let's take a look at that. So the way I like to do this is to just write it out to a log and then grab it. There are other ways. This is actually a well-defined type that you can actually grab. I believe PlayFab even has an entire thing about this. So if you go into tutorials, there's a context models, which is going to talk through all of this. So if you follow the link, it's ak.ms/writing in a PlayFab cloud script. That's going to take you to this sort of landing page, and you can find this tutorial here. But that's going to include things like the title, which is the information about the actual game that you wrote, as well as things like the player who is playing this game. We saw there was things like statistics and things attached to that. We're actually getting that information in our Azure function. We actually have access to all of that. And so we can actually interact with a lot of that stuff. So there's a whole bunch of information here. You can read a little bit more about it and how to use some of this stuff there. But we're going to kind of rely a little bit on the dynamic stuff just because it gives it a little bit more fluidity and we can somewhat change it. For more complicated things, I'm not sure I would continue this pattern. But for just playing around with it, it does make it a little bit simpler because you don't have to wrangle types as much. So that's what we're going to do. So yeah, definitely give it a shot though, and look at this page if that's what you want to learn more about. So let's jump in here and look at this. So we're going to log out our information and we're going to print out the request body. I need to add a quick header here. So we're just going to say request body. That. And so what this is going to do is just add a new log message to our event. It's going to say when this function is invoked, print this out. And so what we're going to do now is subscribe to this. So there's a few things that need to happen here. First, we need to actually deploy this now. We updated our function. So we need to deploy this out to Azure Functions to replace the changes that we made. So this should update that binary out in Azure Functions. Once that's done, we can go over here to our Azure extension and browse the logs for this set of functions. And what this is going to do, we can see this is updating right now. But what that's going to do is actually give us all of these text logs. So we're actually going to be able to see, here's the request body. Here is our HTTP function stuff. All of our log messages should appear in this text stream. So once this finishes, it should be pretty quick. But once that's done, then all we need to do is right click here and do start and stop streaming. So there's a number of different things you can do. All right, we're good. So let's start streaming. Do we want to enable application logging? Sure. So we do that, and now Visual Studio Code is going to open up a new output for us to browse, and from that we can actually see everything that's going on. Connecting to Logstream. All right, so we're good. So let's actually go and invoke this function now. So I'm going to cover everything up again. All right, there we go. And so if I run the game again, we should start seeing logs pop up once I actually invoke the function. So if I log in, you shouldn't see anything pop up here. And why did that stop? Let's start streaming again. Looks like it's already going. So I'm just going to ignore that and pretend like it worked. And we'll see what happens. Not entirely sure why we got that log streaming stopped. But we also aren't seeing any logs. So it seems like we lost that stream. So let's stop it. And we'll just start it again. Because when it doesn't work, press restart and see what happens. So let's try this again. And so we play our game, we log in, and click play now. And now we lose the game a few times, and we should start seeing things pop up. And so these are our same logs that we had previously. So this is the same information here. You can see HTTP trigger function processed. That's coming from here, and so on. So we're getting the same logs. What we're looking for is this request body. And so the reason I like to do it this way is because then I can actually change this and write tests around the request body rather than doing a bunch of other things. So this is just how I work. There are other ways to grab this. Again, there's a strongly typed version of this where you don't need to go and try to figure out what things are. But I'm just going to go and select this entire long line of things and paste this into here. Is this how I want to do this? I don't know if it is. We're going to try it anyway. Actually. All I'm thinking about a bunch of different things. We're going to skip all of that and just do this. So let's do a body. Let's give it our JSON like this. So this is the full request body. And now I'm going to actually push up a new function. There's a whole bunch of things going on here that are hidden, including like where's the player located, things like that. All of that comes in this big blob of data. I'm going to modify my functions slightly just so that I can get that back out. This is less ideal, but it saves me from having to do any formatting. So we're just going to take the request body and send it back. This is an easy way to kind of get around that. There's definitely better ways to do this, but this is fast, so we're going to do that. And there's escape symbols in that string, which make it a little bit hard to just run this through and add the new lines for you. So that's why I do this. But again, there's definitely other ways to do this. This probably is not the most optimized way. It's just something because I typically am not having to strip these things. But there you go. So once this completes, we can run that function and pass in our custom data. And that's actually going to give us all of the information from these functions. We're going to be able to see the entire structure of what is our function is actually receiving, because we're not just getting a name. We're actually not getting a name. We're getting a whole bunch of other stuff. And so we want to see what that is. And so this will give us a quick way to kind of do that. So we've connected there. Let's send this request. And what this is going to do is just mirror this back to us in a nicer formatted way. So there we go. And this is all of our stream information. And so there's a bunch of containing objects storing a bunch of different information for us. So we have the playstream event envelope, the player profile, the player profile truncated, which is Boolean for true or false. So if the player profile is truncated, you're going to get less information. And then the title authentication context, which is going to have information about how you can authenticate with that title. And then generate playstream events is set to true. So this is going to that's the Boolean to let us know if we're generating playstream events. That's what shows up in this terminal for PlayFab here. In your playstream auditor for either a player or for your entire game. So if you want events here, that needs to be true. And if it's true in that function, it just means that it was true and it should be in your playstream. Anyway, there we go. And so now we have all this information. So we can actually look at like the player profile and say, what is this player doing? We can see some information about what title they're playing in, but also the player ID. So we actually have a way to the identifier for that player, so we can actually tie that back to them and use that to invoke other things inside of the PlayFab SDK to interact with that. And so you can also see where it's coming from. So in this case, it's coming from PlayFab. Location, this is going to be the location of where that request is coming from. And then also things like the avatar for the player. Linked accounts, if you've set up different ways for that player to authenticate, as well as their current statistics. So in this case, we have their high score, the tournament wins, and the games played. So we actually have this information here that we can actually reference inside of our Azure function to do other things with this. So if we want to access more information about what's actually happening in our game, this gives us a way to actually do that. We don't need to go and assume or have specific functions written for specific events at specific times. That's not necessarily needed. You can actually get a lot of that information coming directly from all of this inside of the default requests. So that's all there. And you can just kind of figure out what makes sense. Because our object is dynamic, if we want to grab that, we can just go and do that. So we can actually, let's say we want to return the data is the dynamic type that we cast all of this to. grab the player profile.statistics. Statistics. No. We won't get any compilers for this, unfortunately, because again, it's a dynamic type. But what we're doing is trying to grab this. So we're trying to grab all of our statistics and nothing else. And so we just want to look at these statistics and let's deploy that. And so if we run this now, we should be able to deploy this function like that. Click yes to deploy. And so this will update now, and we'll actually be able to drill down into those statistics and have a reference to those. And then this function is just going to return those statistics back to us. So that's all that's happening here. There's nothing super fancy. I'm not intending to write any crazy code here. Just kind of give you some ideas about how you could actually integrate this directly into your game and hopefully use it. I found that these integrations tend to be very specific to the game you're building. So kind of trying to leave that up to you. The really cool thing for me is it's just a really powerful way to kind of interact with Azure and Azure Functions directly from PlayFab in your games, because we still haven't written any code changes that affect our client. That hasn't happened yet. Nothing has changed in our game to make all of this functionality happen. So that's what's going on there. Let's go and launch this. And so if we go and play our game again, so launch the game and do this. We can just quickly log in, play, and lose a few times. And now we'll get this information back. And so because we have this set to execute to PlayFab, we should be able to actually see some of this information come back. So we were filtering out our statistics. So if we look at this, our function result now is just those statistics. Now we're just getting the high score, tournament wins, high score again, and then games played. And so we're getting these different things coming back to us as a way to interact with this. And I think that's mostly everything here. There's two other things that I kind of want to quickly cover, and then we can kind of maybe answer any questions if anybody has any questions. Otherwise, we'll just leave it here. But there is a PlayFab SDK. So if you want your Azure Functions to interact directly with PlayFab, there is a PlayFab SDK for you that you can find on NuGet. It's the PlayFab All SDK, and this gives you access to a bunch of different features. So to add that, we would switch from there to our, I believe we call it Flappy Functions. And so this is our project directory. Interesting. I think I'm using the wrong font in Visual Studio Code. Anyway, so to do this, we just do .NET add package and add PlayFab All SDK. That adds it to our Azure function. Again, everything's bundled into a binary. So by adding this, we would get access to PlayFab stuff. So this includes ways for you to actually send client requests or do polls against PlayFab and interact with that. So if that's something you want, and you want some deeper integrations more than what's coming through there, or you want to have a two-way relationship with PlayFab, so you want to have this function get triggered, but then also send information back about a player or change information about a player or otherwise do something about all the information over there, this is a way you can do that. So that's what's going on there. The other thing is you can actually directly invoke these functions. So if you would like to invoke functions, there is a tutorial for this. So if we go into here, and there we go, I believe it's under this, this quick start. So this is the code that you would use in Unity, for example, to directly invoke your function calls. So if you don't want this to be a trigger based off of an activity or something, and you want to explicitly say, run this function, this is the kind of code you would write. And so what's going on here is, that's a little bit too much. We're going into the Cloud Script API and saying execute a function with a specific function request. This is very similar to the rest of PlayFab's APIs. We have some sort of client that is creating a series of requests and then responding to those. So in this case, we're giving it information about the function name, any parameters we might want to pass in. So if there's custom parameters that the client is going to provide, this gives you a way to do that. You can also toggle with a Boolean whether this should show up in PlayFab's playstream or not. And then the other one is two response handlers. So the first one is a result. So that's for a successful invocation. So if you successfully invoke this API, you'll get that first one. Otherwise, you will get the second one, which is going to be some sort of error handling that you'll want to do. These demos are just logging out information. Probably want something more clear to the player. If for example, your thing to send information back up didn't work, you might want to say more than a log message. But this is a good way to get started if this is what you're looking for. So there's a bunch of information here. And that is, I think, most of the API stuff. If to get started, we can actually, I did this beforehand just because I didn't want to write this. But I do have that same thing implemented here. So what that's doing is invoking our hello world. I don't think that's what that's called. What do we call this? We call it hello Azure Functions. So if we copy that name and paste it here, we'll get that. There's no parameters that we're going to provide. And then we want it to generate playstream events so we can actually see those come through. And then I've added on a little bit of extra error handling just in case things don't work. That's going to give us like HTTP status codes if we need that. So let's go and run this. This is going to need to be attached directly to something. Let me just 1 second. Unity is building. Here we go. All right. So we get our Flappy Cube. I have already added a button here to run a function. So we're just going to attach that. It looks like it's already done. Did I already do that? All right, cool. But basically we need to go and find this, find the class and assign the function that will allow us to actually invoke this. And then we can go and save this, hide this so we don't break our UI, and then click play. And so now if we click login, we should get logged in, and then we can actually send up our function code. And so that will run our function, and we should have seen it here. It did work. Okay. I'm not sure why this is failing exactly. We didn't get an error here, but we did get an error in PlayFab. So we can actually check out what's going on here. I don't know how to fix this, so we probably won't. But it looks like no function named hello Azure Functions was found. I'm not sure. I don't know how to fix this. This is not a feature that I've used very frequently. So unfortunately, I'm not very familiar with how to debug it. But the option is there. If you want to go and invoke functions directly from your game client, you can do that. And one of the advantages of doing that instead of directly invoking your Azure functions is you can put this behind PlayFab Authentication, which means a player has to sign in to their PlayFab account and be authenticated in order to interact with these functions. So that means you're actually going to get information about the player that's signed in, so they can't pretend to be somebody else. It also means that they can't just do that without associating it with some other account. So they have to be signed in order to execute these, which hopefully makes it a little bit nicer for tracking things. And you're not just exposing something that maybe like host tournament or do something else. Maybe you don't want that where just anybody can call an endpoint and suddenly start all these things. This gives you a way to kind of hide that. instead of exposing functions directly. So that's one of the options there. But I think that's everything. Hopefully this was intended as just a really quick overview of ways you can actually add Azure Functions to this and start working with that. Hopefully this was interesting and you and you learned something. If you start using this, I would love to see what you build with it. I think there's a lot of really fun possibilities for adding cloud stuff and game stuff together. So if you do that, let me know because I'd love to hear about it. But other than that, thanks everybody for watching, and I will pass it back to Irina, I think.
Hello, everyone. Well, thank you, everyone, for joining, and thank you, Sam. We would love to hear what you have to say. Please visit the survey for the specific event. It's 15962. If you have any topics you want to hear about in the future, you can also share them there as well. Thank you. Until next time. Bye.
Thanks, everyone.